Well, back here at the excuse me, the Cave of Science, and we're going to do this review of the three assessments that you took today. Uh, One of the ways I'm doing this is because there's many kids that haven't taken the assessment yet, and I don't want to hand it back because then that just makes you know create another assessment for 1 or 2 days here. So I'm going to do this review here, and we'll go through the questions and talk about some of the highlights there. Excuse me. The first one is sun infusion, and so this one's going to look at what fuels the sun, what process gives the sun energy, and then a lot of this is going to look at characteristics of the sun and the sun's formation. Remember, as I mentioned in class, and it's been on every one of these tests, all of your answers are to be in complete sentences. These three tests were very graph intensive, and as I mentioned many times during the school year, use the test as a source of information. And so we'll go through these pictures and these questions, and we'll look at some of these. This will be a good review for if you're going to do the retest. It won't be exactly the same, but it'll be very, very similar. So the first one, the process above, so we're looking at the diagram here, provides the energy for the sun. All right, so we know, we looked at the lectures, we know this has to be fusion. And so what is the name of this process? Well, it is nuclear fusion, as mentioned in the title. What does this process produce? And from lectures and video and class discussions, we know that it produces energy and also helium, the second most abundant element in the universe. How many more years will this process continue in the sun? Well, the sun is going to have a life cycle of about 10 billion years, and it's about halfway through. This was stated directly in the lecture regarding the life cycle of the sun. So it's got about another 5 billion years. The sun's pretty much middle age. Question 2 was strictly a reading question. And the key part here is, what is the mainly responsible for transferring energy to the sun's surface? And as you read through this, they talk about molecules and so forth. But it's interesting to note the convective zone, which is the final 30%, dominated by convection currents that carry energy outward to the surface. That's almost a straight answer, word for word, of the question that was asked. Let's see, go to question number 3. This deals with the formation of the sun, which was one of the lectures we did. And we know stars, or any star, is going to start out as really just clouds and dust, this hydrogen and helium. And then the force of gravity is going to start pulling it together. And then once you get enough gravitational pull and pressure, the star is going to ignite. And when it ignites, that's when fusion takes place. And if we look through the sun, as we've gone through on the lectures on here, the sun will become a supergiant, and like our sun, it'll go to a white dwarf, and then eventually turn into a black dwarf. Our sun, or if something was at least 3 times as massive as our sun, which we discussed in class also, we could go through this scenario at the top here, and you might, if it is very high mass, you'll end up with a black hole. And a black hole, if you remember, is at the center of the galaxies, and it has such a strong gravitational pull that not even light can escape it. Question number 4 over here is the HR diagram. We did a couple different worksheets on this, and we covered this pretty thoroughly in class. First question is, state the relationship between the X and Y values for main sequence stars. Well, as you look on the X, is if you increase the surface temperature, and here it's increasing, what happens? Well, the magnitude, brightness, luminosity, they all increase. We also talked about another relationship, which is indirect on the HR diagram, is that the greater the mass of the star, the greater the brightness also. And conversely, very, very low mass stars, such as white dwarfs, can be very, very hot, but seeing they're so small, they will not be very bright. Most stars belong to this category. well, the main sequence, hence the term main sequence. You guys actually graph this and so forth. Which category or categories of stars will most likely form a black hole? Well, if you go back over here, something with very, very high mass. And from the lecture from a black hole, we know it's got to be at least 3 solar masses. So white dwarfs would not be forming a black hole at all. It had to be some type of supergiant, somewhere up in this range here. Blue-white supergiant could form our black holes. The next question on this particular one is really the exact same thing you did with the sunspots. Here is the graph, and you actually reproduce this, and you determine from the graph there's about a 10 to 11 year in between the solar maximums, and that these solar magnetic days or storm days here, in fact this is the same one that you did in class, they kind of correlate to the peaks here. So there's a definite correlation there. All right, from there, I'm going to go into the Big Bang Theory one. And the Big Bang Theory, as we well know from the Big Bang Theory, it's the theory of how the universe was formed. The first question asks, explain the 2 pieces of evidence. Well, right here, if you look at the diagram, the expansion of the universe, it's pretty much the same diagram I did with the redshift, which we also talked about in class, where everything's moving away from one another. And so the redshift is one piece of evidence that supports expansion of the universe. And the second piece is that cosmic background radiation. And that will strictly, it's right out of the Big Bang Theory lecture. And I happen to mention that is one of the biggest pieces, most important pieces of evidence for the Big Bang Theory. Let's see, you got to find number 2. This element was produced by the Big Bang, and we know there's only 2 elements that was produced by the Big Bang, and that was hydrogen and helium. And hydrogen is important to the formation of stars because it's the fuel for fusion. Question number 3, what 2 forces that contribute to the formation of stars and planets? Definitely gravity, as it starts to pull these stars together. And then we said once you get enough gravity and enough pressure with the material, this pressure is going to ignite fusion. And so those would be the 2 forces. You would have that gravitational pull and then the pressure of all this material. Question number 4, you guys did a whole activity on this, and you have the standard spectrum. And if you look at the lines, which you guys did this in class, you can see that it is actually shifting to the right or towards the infrared, and that whole infrared IR spectrum, the red shift is showing that the whole idea of everything is moving away from the Earth. And I think that was it for that one. The last one, nucleosynthesis, let's see if we can get that one to come up, dealt with black holes. And this is pretty much a question that you probably answered previously. If the sun's mass is 3 times larger, it may form the object that is found in the center of the Milky Way galaxy. And right from the lecture of the Milky Way galaxy, we know that there are going to be black holes. And the thing about a black hole, it has such a strong gravitational field that not even light can escape from it. The last question here, elements lighter than iron, we know, we talked about in class, and you looked at these when you did the star spectrum, that these lighter elements, iron and lighter, are formed during the process of fusion, and the elements heavier than iron, we talked about in class that they are formed during the process of a planetary nebula. The Kahoot we did in class, each of the Kahoot that we went through in class together was really one of the answers for the question of the test here. So this is a review. If you plan on retaking any of these, we'll do that Wednesday, as we're starting to run out of time before the end of the semester. So that's it for that. And if you have a particular question on something, don't be afraid to ask.